Hello and welcome to the first of our panel discussions here at IPC Apex Expo. The topic today is conformal coatings, applications and inspection. And I'm delighted to be joined by three very knowledgeable guests. To my extreme right on the end there, we have George Crom from Rapid Coatings. Welcome, George.
Thank you for having me.
Next to George, we have Mario Gattuso he's the Senior Product and Program Manager at Aculon. Welcome, Mario.
Thank you for having us, Trevor.
Okay, and to my left, we have Camille Seibert from Nordson Electronic Solutions.
It's a pleasure. Thank you.
Okay, so thanks for joining us, guys. Obviously, with conformal coating on the increase with miniaturization and EVs and things like that, and other high reliability electronics, the methods for applying these coatings and inspecting them continues to improve. So we're going to talk about some of these topics today. My first question, and let's just start on the end with you, George, is do we really need to manually mask boards? And if so, what's the minimum masking that is needed? I mean, it's one of these labor-intensive things.
Well, I think it's a perfect question to start off with because keep in mind, I come from the beginning of the surface mount technology world where I built printed circuit boards before surface mount came into the world. Right. And in the beginning, it was like conformal coating is now. And then it became very precise. So the goal is to not mask at all, is to selectively coat. Not too many people are there yet. In fact, I don't know anybody that's really doing that unless the board is designed properly. So in the interim, we've been trying to automate the masking process by 3D printing and things like along those natures. But I think the drive is going to be to eliminate masking altogether.
Yeah, in a world of automation and digitization as we're moving into, that would make a lot of sense for sure. But I mean, how do you avoid, Mario, for example, getting splashing and that kind of thing? I mean, when you're using a material, automatically you get a little bit of splatter with it, don't you?
Well, that's a great question, Trevor. So the question is, how do you avoid splattering? And really what we do is we focus on optimizing the viscosity and the fluid characteristics and matching it with the application's equipment. Usually, if we're working with a customer directly, figuring out what equipment they have or what they're open to, and by optimizing that, you can get extremely finely either dispensed or jetted patterns. And so we're finding that we're able to almost 100% eliminate masking in almost all of our applications.
Wow, that's interesting. So basically doing the combination of getting the viscosity right and getting presumably the valve right that you're going to be using to dispense the material. That's the solution.
Right. The right piece of equipment that's actually doing the dispensing of the fluids and providing the selectivity is all a key part of what makes a successful conformal coating application, especially in a high throughput environment where you're concerned about process consistency and stability, the ability to automate your dispensing pattern and make sure that you have process controls in place to really monitor that overall process and maintain consistency. So you provide the selectivity board after board after board is pretty critical.
Right. So George, how do you restrict capillary flow?
So just to elaborate a little bit on, I agree with them that the material is a key factor in trying to selectively coat. The problem we have in the industry is most of the users are ignorant to the chemical composition of materials. Right. So they're qualifying materials that are much more difficult to use. But anyway, to answer your other question, now a lot of times we'll do some damming. We'll use a material, we'll dam around certain areas so there's no flow into those restricted areas that you want to keep. Yeah. So that's kind of a solution. Again, it adds cost to the product.
Yes.
So if I can tag on to what you just mentioned about customers choosing fluid types that may or may not be appropriate for the type of application, that is definitely an educational factor that we see where there's a responsibility in the industry to provide the knowledge and expertise, especially on the fluid manufacturer side, about what types of fluids are appropriate for the types of applications. And a lot of times it comes down to what it is that you're actually protecting for. Right. So that's one challenge, to make sure that you're choosing the appropriate parameters and fluids to actually meet what the application requires, but then also on the equipment side, our responsibility is to be able to provide solutions for the varieties of different types of applications, whether it's acrylic, hydrophobic, some of the UV cured materials, even, multi-application environments where they are putting down a dam or a masking material first.
Right. Okay. So make sure you have a good relationship with your material supplier, so that you can collaborate on the type of material that you're using and the viscosity, etc. That type of thing. Yeah. So Mario, how important is coating thickness?
Well, for what we're doing, which is essentially most of our technologies focus on waterproofing of boards, coating thickness is critical. But really, the specific thickness depends on what the application is trying to achieve. Are they looking for very incidental protection? Are they looking for very robust waterproofing where they want full immersion capability? And it comes down to matching the coating type, the application process, and matching it with the expectations of the customer. So we typically find that for less robust applications in the manner of microns is typically acceptable, and when properly applied with the right equipment, 30 to 50 microns can get very, very robust levels of protection.
Okay.
I would say for your typical conformal coating fluids, you're ranging between 75 and up to 125 microns. On a populated board, silicones have an additional room for
That's quite a bit
thickness.
more than Mario's suggesting. I mean,
Yeah,
that's almost double.
One of the things that we run into is with a lot of the more traditional coatings is they'll get non-uniformity on the components and where the material actually will slump off the edges. And what we find is that it doesn't matter how well protected 90% of the board, if 10% doesn't have that level of thickness and it's exposed to something that's going to damage the board, it's going to fail.
Interesting.
So what we found is if we get a uniform coating that's a bit thinner, we do get that level of protection.
I see you grinning on the end there,
I
George.
love being here with these young minds because that's what we need. What I will tell you is when I started this business after my first life of building printed circuit boards, which I used to talk people out of conformal coating, the consumer, the customer is ignorant to the thickness of the material. I thought people were going to ask for the thickness and control the thickness. Doesn't happen. I have over 100 customers. There's only a handful that ask for the thickness.
Well, depending on the application, it's actually quite critical. But my next point was going to be that a lot of the inspection systems that are out there at the moment only just measure for coverage. They inspect for coverage. They don't actually really inspect for thickness, do they?
I know that there are some that do. We have a sister company within Nordson who definitely offers thickness measurement capabilities. So we do see that come up, especially for a lot of the high reliability, high volume environments. They do care about their thickness. The trick is they make sure that they set up the process correctly at the beginning, and then make sure that they have a lot of checks and balances in place to maintain that process, days and days on end.
So one of the problems in the industry today is if you were to get an AOI that acts like it does for printed circuit boards, you can't find one.
Right.
Now, Nordson does have, YesTech it is, does have the leading edge, but they're not there yet. Because the problem is the process is not that repeatable yet. And I'm talking about high mix. High volume is a different world. I'm in a high mix environment, very high mix. Meaning, I'll do 25 boards, 15 boards, 100 boards. So the problem is the programming takes some time, and then the exact science of the process has to be controlled. It's difficult. It's very difficult.
Right.
So in a volume world, it's a lot easier. One product, you dial it in, and so.
Mario, you got something to contribute?
Yeah, I would mirror that comment that thickness mapping of a three-dimensional part is fairly difficult, especially if you're going to do every one. So it really comes down to a matter of finding a way to correlate the fluid behavior and the settings on the application equipment to confirm that they're behaving as they should be, while you're doing your run.
So how do you get, Camille? How do you get to speed up the setup process? For these if you are going to a more high mix environment. I mean, Is there a way? Are you working on a roadmap to try and do that?
Yeah, absolutely. So historically, a lot of conformal coating has been referred to as an art rather than a science, and a lot of what we're doing is adding more of the science to it. So obviously, there's an art with how the fluid is laid down. So part of what we're trying to do is include kind of some of the best known methods that we have for laying down fluid and things like that,
Right.
and making sure that that gets incorporated into the software, and then adding a lot of data driven calculators and features to the software to help the user actually establish a process pretty quickly that is going to get them pretty close to where they need to be for a conformal coating process.
Okay. All right, let's move on to my next question. George, what are the pros and cons of chemical vapor deposition versus spray coating?
Well, I wish I could answer that question because I have no experience directly with
CVD.
with Paralene. You're talking about like that type of, right now we're spraying, a dispensing. We're doing all those methods for assembly. I have not ventured into that, which is, I believe, a lot more exact than what we're doing.
Right.
And her comments are right on, because, in the early stages of surface mount, the false failures that you saw with AOI was incredible.
That's true. Yeah.
Now you don't hardly have any false failures, but the false failures in conformal coating, especially spraying it, because the chemical people aren't communicating with the valve people and then the assembler. And, the majority of people are doing it in their back rooms with a spray can. I'm serious.
So there you go, Mario. You want to pick that one up? You're not talking enough to the valve people.
Well, I think he brings up an excellent point. I think it is what we found is that it is critical that when you're, especially in a lot of these high volume applications, when you're customizing a fluid or you're customizing the equipment, a process, it's really a team effort. It's not the fluid supplier and the customer. It's not the equipment supplier and the customer. It's the equipment supplier, the fluid supplier, and the customer working as a team together to get this done. What we found is extremely critical.
Okay.
I had another point that I wanted to add on, but maybe I'll think
You'll
about
come
it.
back round. Okay.
We didn't get to be my age.
Yeah. So, Camille, I mean, do you have any experience of using CVD versus spray coating, or?
So I'm obviously Nordson is more on the spray coating side, but within the industry, the chemical vapor deposition process has a place. So depending on the industry that you're in and the type of reliability that you're looking for, that strict uniformity, full 100% coverage is more critical in certain applications. So
It's
some
more in
of
the
like,
semiconductor space. Yeah.
and some of the military aerospace type applications really demand more of that uniform coverage than, say, some of the rest of the industry, which is trying to balance the need of full coverage versus functional coverage and making sure that they're strategically applying the coating to components that need it, as opposed to just unilaterally covering the entire board.
Okay. All right. Thank you for that. I'm going to move on to our next question because I want to try and get through as many as we can in the time we've got. So back to you, George. What are the benefits of UV curing acrylics versus thermal curing of polyurethanes?
Well, if we didn't have the masking issue, UV curing would be across the board. It'd be the best way to go because it's fast.
Fast, yeah.
The problem we experience with UV curing is simple that if you if you cure before you demask, it's a nightmare.
Right. Any comments on that, Mario?
So with what we do, we actually avoid UV and thermal curing, so we don't have a lot of experience there. What we're finding is that most of the time, in order to increase throughput, if we can eliminate steps, it's desirable. And so what we found is if you can provide a solvent-based system that's VOC-free, that provides a significant benefit over having to do any sort of thermal or UV cure.
Okay. So, what about you? Any thoughts on that particular topic?
So it kind of goes back a ways to what is the fluid that you're using and how does that apply to the application that you're actually protecting for? So different environments require different types of fluid. If you're interested in more workability and things like that, then sticking with some of the acrylics is going to provide a benefit. In a lot of environments where you want to make sure that you have maybe more chemical resistance and things like that,
Right.
going to something that has more of a thermoset that it actually fully cures and cross-links as opposed to able to being dissolved
Reworked.
and reworked.
Yeah.
Those are different considerations, and then picking the appropriate curing method to go with it and the different considerations around the right curing profile and timing around that is probably more critical.
Yeah, that's a good point. If you need to rework it, then you need to be able to have access to it. So let's see. We'll stick with you for now, Camille. What problems do cracks and ripples to the coating cause?
Pretty significant ones.
Yeah.
So going back to the curing profile is important. Making sure that you're curing at the right speed. That way you prevent the introduction of cracks and orange peels, which can cause and introduce added stresses to the board. So the whole point of conformal coating is to increase the reliability of the board. But if you apply your coating too thick or if you cure too quickly and you get the orange peel, your fluid is kind of shrinking, and so then you're introducing stresses on leads and joints that you're intending to protect.
Right. Okay. So that brings in the orange peel where it delaminates at the edges, but on cracks, do cracks appear for the same reason?
Cracks also appear if you have an issue in your curing profile, and with those, in addition to potential stresses that you're introducing, obviously now you're creating open areas in your conformal coating. So now the protection that you're trying to get from moisture and dust and things like that is now kind of moot.
Right. Anyone got anything to add on that topic of cracks and ripples and?
Yeah. I would add that avoiding cracks, especially, is critical for what we're looking for waterproofing.
Mm-hmm.
Any sort of cracking can act as a pathway for moisture, for water to get in and access an area. And like I was stating earlier with component edge coverage, doesn't matter if 99% of the board is coated perfectly. If you have that 1% area that's failing, then you're going to have a failed board. Ripples is the same thing. If you have a coating that's too thin, then you're going to get current leakage and you're going to get corrosion underneath that coating, regardless of whether there's a pathway or not.
Really? Okay.
The other big variable is the cleanliness of the board. So we can experience in the process, a customer will send us some product and they've handled the board. So just the oils on
fingerprints and that type of thing.
Amazing, and also to Camille's point, the outgassing becomes critical. So depending on the chemical, it's not an easy process. I always thought surface mount was hard, but then but there's a lot of variables. I mean, the ambient becomes a huge, the humidity. So there's all these variables that you're dealing with, and so many different chemicals.
Right.
That's the other thing you're dealing with. So it's a very difficult process.
Yeah. I mean, some people, you mentioned cleaning there, George. I mean, some people are using aqueous cleaning for boards. Some are actually doing a plasma treatment to try and get a better surface tension. For coating, for boards that are going to be coated, is plasma treatment a good idea?
See, as a contract manufacturer,
right,
plasma could destroy some components. I have assemblies going through the facility that are worth $16,000.
Right.
So, just one assembly. So we have to handle those with kid gloves. And the plasma is the way to do it, but you have to get the approval from the customer as a contract manufacturer. Again, being an OEM, you can put all these things in place, and you could get that repeatability. You could get that processing control. But, that's why the industry hasn't really adopted the contract manufacturing philosophy. I don't have a lot of competitors. And because, like I said, most people are doing it, most people are trying to avoid it, is what they're trying to do.
Right.
But it's catching on. That's the other thing. now people are, it's like insurance,
Right.
you know, so.
Yeah, so the introduction of plasma treatment before conformal coating definitely has benefits as far as improving adhesion, and that is more of a surface treatment as opposed to a cleaning per se.
Right.
So it's still important and critical to make sure that your boards are clean so you don't have de-wetting issues from residue that gets left behind and things like that. And the plasma treatment helps to adhere the conformal coating fluid to the board. You also have the consequence then where your fluid is going to wet out more. So there's a consideration from a process perspective in that aspect. But in general, to George's point, for the applications that don't need it, there hasn't been much of an adoption of it because it's an added process step.
Of course, yeah, and cost, of course.
And bubbles too. I mean, I don't know. I'm still trying to figure out where sometimes the bubbles come. It's usually it gets some air in the feed of the equipment. So you have to control that as well. So the industry itself is trying to figure this out. And for an OEM, for a volume guy, it's a lot simpler. For like I mentioned before, there's so much variety of product out there, and and every printed circuit board is different.
Right. Yeah. But the bubbles sound is probably a valve issue. They're pushing out too hard or something.
Bubbles come from a number of different places.
Okay. I think we're on. Yeah.
Okay. Bubbles come from a number of different places. So they can get introduced from the valve actuation. They can also get introduced from the fluid itself, either refilling a reservoir or some fluids like silicones actually incorporate air into the fluid. So then when they come out and they're dispensed, then they can release those air bubbles and you'll see that. But then even just the interaction between the fluid and the board, I mean, the whole point of conformal coating is that you're dispensing overpopulated components which have air trapped underneath them. So as soon as you have a fluid layer that goes on top, you start displacing that air underneath. Yeah. And voila, then you
so
have bubbles.
Is thermal processing then a preferred route to be able to outgas these bubbles? Is that, for curing?
A lot of times it's not possible. For example, we had a particular situation, and it was silicon, I believe, that we had to put a pressurized tank. So, there was weight on a sealed bag inside a container because before that it was grabbing air, we don't know where. And then the other thing is the speed of the machine. The faster you want to go, the more potential to pick up some air.
Right.
So, so...
All right, so we're starting to run out of time, but I'm going to come to my last question. I'll start with you, Mario. Are two-part coating materials more reliable, and if so, why?
Well, we don't actually have any experience with two-part coating, so everything that we do is one part.
Is one part, okay.
So what we're trying to achieve with our customers, we've all found that one part is perfectly reliable as long as we're optimizing the correct coating for the application. So at this time, we're not seeing a need to move towards two-part coatings. For us, it looks like an added unnecessary step to have to mix.
Using any two parts, George?
We do have two parts, and if you were to ask me about reliability, I don't have a clue. Every customer thinks their particular chemical they're using is the best reliability.
Right.
Now, if you want, you probably should ask Elon, because I think whatever he's using is probably the most reliable. But two-part is not, it's a very small percentage of what we see.
Right. Okay. Well, I know that you work in two-part materials, Camille, so what's your take on it?
So two parts definitely have a place. There's the added benefit that you get a definite cure that comes at the end, whereas some of the UVs you have shadowing, so you might not necessarily get that full cure under components that are blocked, even though there is a secondary moisture cure on those types of fluids as well. So verifying that you have a complete cure is a challenge for conformal coating applications, and so the two component does provide kind of that reassurance, but in a manufacturing environment, that mix that's required for the two component, maintaining that mix, in a lot of cases is more than what a lot of the industry is looking to deal with. So we still see a significant majority of the industry doing single components.
Single components, yeah. Okay, great. Well, I want to thank you all guys for giving us, imparting your wisdom today. It's been a good debate. We covered a number of topics. So for now, I want to thank you for coming in. George Grom there on the end.
Thank you.
Yep. Mario Guzzo from Aculon.
Thank you.
And of course, Camille Siebert from Nordson Electronic Materials.
Thank you, Trevor.
Okay. Thank you for joining us, and thank you to our audience. Coming up after the break, we'll be moving on to our next panel discussion today. And that will be, let me tell you quickly, line optimization and interconnection using inspection software suites. So that'll be coming up later this morning. Thank you.